many of these tools today have turned the operators, the marketers, the traders, whatever you call them, have turned them into the computers. And I mean that in the original sense of the word computer, which referred to people that did mathematics and entered it into computer systems. People are spending all their time doing this rather than thinking, innovating, and being creative about marketing strategies and new ways to market. And we can change that.
Hi, I'm Greg Stewart, CEO of MMA Global, the international nonprofit trade association for CMOs who are focused on architecting a new future of marketing.
I'm Rex Briggs, an author, market researcher, measurement inventor, and entrepreneur.
Hi, I'm Greg Stewart, CEO of Marketing Media Alliance.
I'm Rex Briggs, an author, marketing researcher, and entrepreneur, and this is Decoding AI for Marketing.
Okay, Rex, I couldn't be even more excited. This one today in particular is really going to get your attention. So as you know, we do a lot of sort of marketers. We bring in some entrepreneurs and so on the show. But this is a time to really dig into the mind of one of the original OGs, the guy who's been doing machine learning and AI and ad tech forever. I mean, longer than anybody else I've ever known. I mean, clearly his time is 9. I think you're going to really like today's guest.
Yeah, absolutely. I'm really excited to dig deeper into the history with DSPs, and there was some machine learning in there, but, hearing how much it really is there. But the really interesting part is that we've been running this business where humans surround a little bit of technology, and we're shifting to a world where we now have lots of technology surrounded by a little bit of humans. What is that jump when you have agentic systems, machine learning, and generative AI all coming together? How fast is it already here? How fast do we need to be going? I think that's going to be a really big part of the conversation today, right?
Yeah, I think clearly the answer to our conversation I had earlier today, not nearly fast enough. So listen, let me get right into it here. So listen, the gentleman we're speaking to, I actually had dinner with him in Berlin at an event that he and I spoke at for the MMA there just a little while ago. And I was fascinated by the range of conversations. So we're going to introduce here Konrad Feldman, who's the co-founder and CEO of Quantcast. He's been 20 years there. That's a native AI DSP. I'm not sure everybody knows that. Konrad actually has a background from UCL. If you don't know, that is the original, that's where DeepMind came out of, which is modern AI. So we'll have Konrad sort of give more details to that, but I'm super excited to have him to tell us what he's learned the last 20 years in trying to apply machine learning and AI to the programmatic advertising world.
Welcome, Konrad. So maybe give a little bit of your background, how you got into this, the crazy space of advertising, because you didn't start there, and then give us a little bit of your perspective on where things are at and where they need to go.
Sure. So, I started my career actually as a researcher in AI in a field called neural networks. So this sort of the origins of neural networks is sort of looking at the brain. And obviously there's something about the way our brains are organized with these simple processing units called neurons, and you get a lot of them, and our intelligence emerges from it, and that inspired researchers. So I started working in the mid-90s on neural networks as a researcher at UCL. I was working on a PhD in neural networks, and I didn't complete that PhD. I started getting involved in doing work applying these AI techniques to help businesses understand and interpret all the data that they were processing. And I built a company with some of the postdocs at UCL, and we applied this technology predominantly in the financial services space to interpret and understand transaction patterns in big banks. The banking industry was going through this evolution from being all in person in branches to telephone banking and internet banking. And with that, they lost a lot of the distributed intelligence of the people, the bank tellers and so on, in the business. And we were using these new computing techniques to reintroduce some of that context and intelligence. And so as that company grew, I moved actually to the US, and completely coincidentally, I think it was around 2000, was introduced to Alta Vista. So probably no one remembers them now, but at the time they were the biggest search engine in the world. You
I remember.
We're old enough. I loved it.
It was like finally somebody got search really right. That was Alta Vista. And then crushed.
The first non-directory that really made a big difference, laying the foundation for what came out. Funny thing, I was working at Wired. We tried a neural network early on. This would have been 95 with Fair Isaac, so people that do the FICO score. And we could predict who is going to become be still a customer visiting web pages about 60 days out based upon their first week of site visiting. But when the search engine came, we had Hotbot, where that was an Alta Vista competitor. All of a sudden, all the data we were processing, which normally we could crank through in about 6 hours, 24 hours later, we couldn't crank through it to be able to deliver the overnight data to know how everything was going. So it's been interesting when you think about that 30 years and what you've been working on. You're working on that early stage of neural networks, but the compute was so limited and the amount of data was so limited. My God, I mean, you've watched it firsthand, this massive advance. What stands out to you most? And I mean, so you saw Alta Vista, that got you involved in marketing. What made you launch a company? And what did you see became the changing point with compute or technology that said, hey, there's a lot more we can do here?
So what first caught my attention, and I spent my whole career helping interpret data. I've learned about businesses by the data they generate, and looking at internet data to me was just fascinating. The sheer volume of it, the ability to understand the world through it was really interesting to me. And the data volumes were daunting. And that was back in 2000. When we launched Quantcast in 2006, the internet was much smaller than it is today, but the volumes of data were, as you mentioned, they were already breaking the sort of the traditional data processing paradigms. And so we had to invent it. And I think if you look at sort of the history of AI, and I think so many people think of AI has been something that appeared over the last sort of 3 or 4 years with ChatGPT, and certainly the large language models are a major advance. But this is a history going back to the 1950s. I mean, theoretically, back before that into the 1940s, all the way back from Alan Turing.
The perceptrons,
Totally.
Way back, right?
Totally.
Sure.
And the advancements that we've seen have been this sort of constant interplay of innovation and development in hardware, in the compute infrastructure. Obviously, computers always get faster, Moore's law. Maybe that will end at some point. But then we have specialized architectures, GPUs, TPUs, advances in the various algorithms. So the original perceptron that you mentioned, and then go forward backpropagation and deep learning, and then transformers. But also the sheer availability of data. In today's business world, we take it for granted that we're inundated with data. That was not always the case. And the internet made a big difference because it allowed researchers to start sharing data sets to learn from, and the amount of data you have and the quality of that data makes a big difference. But we've obviously got to the point today where the internet's not just a mechanism for sharing data, it is data. And so if you think about how all these things have come together, we get to this sort of remarkable place where we are able to interact with these AI systems, 1 billion people around the world using them regularly, and that's been driven by advances in all those dimensions. And you can wait for those things to happen, but if you really want to imagine what the future is going to look like, you need to invent it as well. And so along the way, we've had to invent mechanisms for storing massive data sets and organizing those data sets, and how to run these sort of machine learning models at industrial scale so that we can build custom machine learning algorithms essentially for every single advertiser that we work with.
Yeah, and you only have like 50 milliseconds or 100 milliseconds to make a decision. And just for the listeners, that's the amount of time it takes for you to blink your eyes. I mean, so it's a very different thing where Gen AI, you can wait for, it can have this thinking time, it can have this loop, and you're okay waiting. It sort of streams maybe an answer and begins to fill itself out. You have to do a lot of things that operate at a much, much faster speed. So take us to the world of what you think the world looks like today and in the very near term, like 2026, with the combination of machine learning. Maybe, I think you said before that there's a misnomer that a lot of the DSPs in the digital had a lot of machine learning, because it was actually pretty much light. It was light on that. It was almost more of a marketing claim of, oh yeah, we've got machine learning doing all that stuff. But it was really just human rules that got calcified in the infrastructure at some point. Can you unpack that a bit more?
Yeah, absolutely. So, if we go back a few years now, if we go back to the birth of programmatic, let's step back just before that. What software was most commonly used for optimizing media buys before programmatic?
The funny story is, at Wired they had
Excel
a 19 Excel, and then there was a Wired had their ad server, the Scipitor, and a few of the other earlier NetGravity used was based upon a coin flip, which is if you run out of time and trying to work the decision tree, you just coin flip and decide what to do is actually based on the 1970s nuclear fire code that the U.S. was using, that if you couldn't decide if we were being attacked, at some point you just flipped a coin to fire your missiles or not.
That's really reassuring.
But Konrad, what did you see though that got you into the ad business? So why come after that? Kind of to the earlier discussion there.
Well, my initial interest was actually to do with the data. I thought the data sets were so fascinating, and obviously it was clear that the internet was going to be immensely transformative, just as it's clear today that AI will be. And so actually, along with my co-founder, actually it was a client of mine, I'd met him, he was running engineering at Alta Vista, Paul, and we were looking at a range of different areas that involved analyzing internet data, and advertising caught our attention. I think part of the reason was, obviously, back after the dot-com bubble burst, sort of internet advertising appeared to die. But you fast forward, then Google had gone public and people realized, internet advertising is a real thing.
Yes.
And what puzzled me, what I was curious about was, if I was using a search engine, the ads were relevant. The ads were useful, and advertising performance, getting results for advertisers, getting monetization and yield for publishers is all about creating relevant, useful experiences for consumers. The ads in search were relevant, but if I went to a website, or either of you went to a website,
they sucked.
They
sucked. You heard it from Greg first.
It's a technical term, Konrad. We call it sucks. Yeah.
It did suck, but I didn't know why, because I didn't know anything about advertising.
Yeah.
So actually, I put help wanted ads on Craigslist, and asked people if they could explain advertising to us. And we used to meet them mostly in a bar just around the corner from me in San Francisco.
Oh, so they were real advertising
really
people.
Questions.
That's good. Right.
How do you know who you want to advertise to? How do you know where they are? And through this process and through learning about the briefs and the personas and the RFPs, we discovered that the problem was data. So if you want to modify content in real time, in 50 milliseconds, to be responsive to consumers, you have to use a computer to do that. And the decision-making apparatus of a computer is an algorithm. And algorithms are like recipes. And they need ingredients. And the ingredients for those algorithms are data. Now, with search, the data that a search advertising algorithm needs to make decisions are the keywords you type in. And you cannot do a search without typing in keywords. But when we looked at these briefs, they didn't really talk about keywords. Often they didn't talk about context. They talked about the desirable characteristics of that ideal audience, the persona.
Right.
And it could be demographics and interests and lifestyle, aspirations, habits.
Yeah, that's what it was still demographically based, because that's how the traditional media was still doing it.
Yeah, there was lots of that. But importantly, whilst you cannot do a search without typing in keywords and transmitting those keywords to the search engine algorithm, when you visit a website, the ad server on that site had no knowledge about those other characteristics at all. And as we dug deeper, we found out that actually most sites on the internet didn't have any audience information at all, because the traditional measurement approaches, which were sort of statistical sampling based on panels, as the number of media choices grew, the sampling area just went way up. In fact, most television stations didn't have accurate data. The website, the internet had millions of websites. There was no data for the vast majority of them.
And by
so
data, you mean you didn't know who the consumer was. You didn't have any
you didn't even know who the whole audience was. You didn't know the aggregate characteristics.
because they weren't
let alone an individual.
Yeah, they weren't doing a lot. Not everybody was making you sign in at that point, so they weren't collecting their own, as we call first party. They probably weren't collecting also their traffic data about where people are going and visiting, even at some levels, what you're saying?
And the panels got too thin because you have this long tail where if you only have a 1 million person panel, but only 50,000 people visit the website, the 50,000 as a percentage of the total U.S. population at call it 321 million people is too thin, right? So you've got zero cell or maybe 1 or 2 people, not statistically significant to understand the profile of who's visiting that particular page. It's a long tail problem, basically.
And that was for the audience of the entire site. Yeah. What if you wanted to make a decision about the individual impressions so you could create relevance for the individuals? It was clear that panels were never going to get there. And we had this idea, it was a hypothesis at the time, that if we had enough of sort of the underlying data, the underlying transport data of how internet content is moved around, we could apply these machine learning techniques to actually understand the types of audience characteristics that advertisers were looking for when they sent out RFPs. And so we ran a bunch of experiments and convinced ourselves that it was theoretically possible if we had enough data and if we could develop sort of the type of compute infrastructure that could process these enormous sets of data. I mean, you mentioned the site you were working with struggling to keep up with their weblogs. Imagine trying to manage the weblogs of millions of web destinations simultaneously. And that's what we had to do at Quantcast.
And Konrad, not to, listen, I want to jump ahead here pretty quick, but the original Quantcast business model, as I recall, because I was there, I remember you, and I remember what you guys were doing. A bunch of my friends who worked there, was that you guys were capturing publisher data to help tell them what the hell was going on because they had no idea. And then you were using that data in order to build another programmatic advertising stack, right?
That's right. The first problem we sought to solve
very smart. Yeah.
was to help publishers understand their audiences. The challenge that, if you're Google or Facebook, you see everyone and you see a broad range, very sort of diverse range of behaviors and interests. That helps you understand audiences. If you're an individual website, even if you're a really big website, you're seeing a narrow slice of the internet. So what we created with Quantcast Measure was essentially an enormous data clean room for publishers. Where they could securely share their data with an algorithm that could benefit from understanding that a particular audience didn't just have interests in that site, their interests were diverse. That individual publisher had no way of seeing that, but by cooperating in this, machine learning models, generally speaking, the more data you have, the better. We could then start to understand these nuanced characteristics of different audiences and help publishers, better understand their audiences to produce content, but also better satisfy advertisers.
Yeah. So, Konrad, let's jump way ahead because now we're talking about what a little red wagon looked like. Okay? All due respects. As amazing as that was, okay, and a big deal, what's happening today? That's what caught my attention at dinner on what modern AI advertising systems are really having to do and the complexity that's going on. And listen, you're fine to talk about Quantcast any way you want to go at it, but go.
So, you have a couple of different types of systems. I think you have the types of systems that most advertisers in the world will use, let's say, Google Search, Meta's ad platform, and there you have, goal-driven, autonomous advertising. And it's the reason it can satisfy the needs of, 10 million plus advertisers. When you look on the open internet, one of the reasons the open internet captures a disproportionately small share of ad spend relative to the walled gardens is it's harder to buy. The thing that makes it really attractive for consumers, the fragmentation and diversity, makes it more difficult to buy. And the systems that have been created to deal with that complexity are referred to as demand-side platforms. And, they were introduced when Excel couldn't keep up. And they are examples, traditional DSPs are examples of systems that are called expert systems. So in this long journey of artificial intelligence, the neural networks that underpin large language models, they've gone through a couple of cycles of massive optimism and then disappointment when they couldn't scale. In that first cycle of disappointment, people sort of researchers said, well, look, we can't simulate on a computer the human brain, but we can go and ask experts how they make decisions and capture all of that logic. And expert systems are really widely used. They're very, very powerful, but they're limited when the problems get very complex because it's expensive to set up all the rules. And if in real world problems, those rules are quickly out of date. That's where DSPs emerge from. And as programmatic has gotten more complex, more channels, more formats, more metrics, it's been harder and harder to keep up. And today, these systems require enormous amounts of use to try and maintain these rules. Now, we've taken a really fundamentally different approach, an approach that's much more akin to the sort of the big ad platforms you see in the walled gardens, which is, rather than start with a hypothesis about the configuration, we start with a clear goal. And there's lots of different types of machine learning techniques, but all of them are goal-oriented algorithms. So we start with an example, for example, people that are converting on a marketer's website. And we then use actually a whole host of integrated machine learning algorithms to determine, okay, from this, how do we predict the audiences that are most likely to be interested in this particular advertiser's products or services? What context is most relevant? And these models, these aren't static. This is not based on static third-party segments and a fixed model. These are continuously learning and updated in real time. And it provides a couple of massive One is it just performs much better. The traditional DSPs are constrained by human thinking. Human thinking is incredible. Our
but
intelligence is, well, it's limited in certain ways. Our brains evolved to help our survival. They helped us, work out the right way to throw a spear in a three-dimensional world. And we can think very clearly in 3 dimensions, but it's hard for us to think beyond that. The digital world is not constrained like the physical world. When you're able to interpret data and information in higher dimensional spaces, you can find more nuanced patterns and characteristics that can help you be much more predictive. And
taking your spear analogy a little bit more.
Sorry.
Yeah.
Oh, sorry. Yeah, I was just saying.
Yeah. Hey, Rex, I got to be clear. I'm not up on my spear throwing. Okay, just so you know, I'm a little lax on my spear throwing skills here late.
Well, I'm thinking about the
Sorry, guys,
analogy.
My phone was going off, and I stopped hearing you.
Yeah. Okay.
Gotcha.
Yeah, we got you.
Yeah. So I think. So just picking up on your spear throwing, because that's actually perfect for targeted advertising. That's if I take your analogy, then the expert decision was the human caveman throwing the spear at the marketer to say that's who I want to reach with my message. The spear is the message. Now what you're saying is we're taking machine learning lookalike models. Instead of you as a human throwing the spear to sending the message to the person you want to hit, you should set up a goal, which is you're trying to get something in that population to buy something or to interact or to visit a web page, download an app, whatever that KPI is. And you're better off saying, look, instead of throwing one spear at a time, one person at a time, and not being perfect in your targeting, if you actually observe what you want the outcome to be, let the feedback channel tune the model continuously, you will get more conversions, you'll sell more product, you'll achieve better results. Is that kind of
exactly
level
right,
one of the
Rex.
machine? So that's the machine learning part. What else do you think happens next on that?
So, to actually deliver a success. Oh, I see what you mean. Well, I think there's several pieces of it. First of all, that ability to recognize that your target audience is rarely homogeneous. There's all sorts of different types of people and different attributes and different characteristics. And when we describe a homogeneous persona, we really mean the largest group, the largest single group. But there's actually
That's a great point.
There's lots of subgroups, and it's hard for our brains to get our heads around that because we're limited in how much information we can sort of hold in our memory and the way we can sort of build these models. But machines aren't limited that way. So they can understand all of these different nuanced subgroups that are actually constantly changing. So that's one aspect of it. Clearly, with advances in generative AI, there's going to be opportunities to modify messaging there as well. I think that's an exciting area.
You bet.
Of,
Personalized ads is a big
research and
deal.
development. I think probably the full true value of data-driven advertising and creating relevant experiences to consumers, needs that sort of personalization. And I think we're going to see more of that, not just in advertising, but across marketing in terms of the customer experience. Not just because we can. Consumers are going to demand it.
Hey Konrad, what's it going to take technically to get all that right? Like, listen, you've got a lot of complexity here. So you've got to have data. I mean, listen, don't let the dumb guy here explain all this to you tech guys. But it's like, you got a database. You have access to that database, having to make split-second decisions. You're having to build cohorts of audiences. You're having to create generative personalization of ads because we can't have Gen AI can't produce an ad fast enough, I don't think, from what I've seen so far. So I guess maybe walk through the listener, like, what do you think the steps, where are we now, where are the steps, what's it going to look like would be really good? Because you're probably going to see that better than anybody. What's really possible? Yeah.
So I think one thing to recognize is where we are on the AI journey today. We're not yet at the point of what would be called artificial general intelligence.
Right.
Which is a sort of a single machine learning or AI approach that can sort of do anything that humans can do. We're working today with narrow AI, which is designed and tuned for particular tasks. And I think what we're seeing that's so impressive is that some of these large language models can take on a broader range of tasks. But behind the scenes, there's still, many researchers computer scientists who are thinking about how to organize, how to break these problems apart. And so that's a really important part of it right now, is understanding what's possible, how do you break it apart, how do you deal, rather than trying to deal with every case, all of these things are like 80-20. Maybe you don't have to produce a new creative for everyone. You have to produce a new creative for the things that come up most frequently, and you can plan those a little bit ahead. So there's intelligent design that goes into this as well. We're not yet at the point where the computers, you just give them a simple instruction and they just go and do everything for you. There's a lot of deep technical expertise that's required to piece these things together, to break the problem down into different subtasks that you could then assign agents to that can operate. Then you've also got to think about how do you orchestrate them, how do you keep them all working together.
It seems like data is a really important ingredient. And I know part of the bridge between the first generation you're describing were the panels that were used for magazines and television before it didn't scale to the internet. And that's where identity graphs sort of emerged and began to become a glue to map different data for almost everybody. And then, as you described, the lookalike, machine learning, or act-alike models were really important, but they only worked if you had a lot of data, at least the signal of what the conversion was, but ideally additional data that could help you decision more intelligently or predict more intelligently. It seems like what you're also pointing out is some of the DSPs that are still in the old expert rules-based, you pick who you want as an audience and persona, and you don't really have that lookalike, act-alike, they're going to have a hard time making this jump because they don't have a bunch of data beyond just the conversion to describe who the people are. Is that right? And how should I think about how does a marketer get from here to the promised land you're describing?
Yeah, their architectures aren't well suited. Look, their architectures, you can put large language model style AI on top to try and automate tasks that humans were doing, but the way in which they allow you to configure and make decisions is still constrained by the fact that it was developed for humans to make those decisions. So maybe it can make them a little bit better, but not transformatively better. You need a different underlying architecture.
Describe that architecture, what you need, because I think that's the kind of a really interesting observation.
So you need a way, first of all, you have to move beyond third-party segments. You need to work from signals rather than segments, and ideally you can operate at the atomic level on trillions and trillions of these signals. You need to be able to build these sort of predictive machine learning models at essentially industrial scale. We build a unique predictive audience model for every single campaign, and that model is maintained in real time and scored in real time. So you're always maximizing relevance. If you want to be able to produce insights, even provide interesting reporting, you need to be able to allow humans to interact with that data in real time as well. And that means, moving, an enormous number of computer bytes around rapidly to make it seamless and intuitive. But one of the advantages I mentioned of this technology is it makes ad performance a lot better, not just a little bit better, a lot better. But it also dramatically simplifies the process of using a DSP, because you no longer have to concern yourself with pulling all of these levers. If you've been in a Waymo, so I'm in San Francisco. If you go out on the streets here, we have lots of these self-driving taxis called Waymos.
Yep.
And they're terrific. And they're already much better drivers than the average human. And they change the game, and they get better all the time. So, and they free up people's time. So using the Quantcast DSP, you no longer have to be pulling all the levers. If you want to experiment, if you want to try out a new media strategy, with a traditional DSP, you're just doubling your work. With our DSP, it's really easy to try it out, experiment with it in an A/B framework, see what works and move on. So I think of it as, ultimately making marketing more human. Many of these tools today have turned the operators, the marketers, the traders, whatever you call them, have turned them into the computers. And I mean that in the original sense of the word computer, which referred to people that did mathematics and entered it into computer systems. People are spending all their time doing this rather than thinking, innovating and being creative about marketing strategies and new ways to market. And we can change that. We're already changing that, and AI has the potential to really free up humans to be much more creative and innovative.
Hey, Konrad, we were talking at dinner. You and I got a little bit into the self-driving cars, the Waymos, and I think Zox is the other one. There's a few out there that are coming along. And yes, I think everybody who knows anything about that, what they tell me is that let's get to 98% self-driving cars so that we can start saving lives. Because just humans are terrible drivers. But listen, you also mentioned though it requires a lot of AI systems. It's not just one AI; it's multiple AIs. Can you take that I don't know if the listener cares about for cars. Can you explain that though in advertising? What are some of these different AI systems that you think have to be created that sort of support ultimately the best in breed advertising?
Well, I'll give you some examples of what we put together.
Great.
There's a set of algorithms that are responsible for building audience models. There's different ones that are responsible for understanding context and then building unique contextual models for each advertiser. When it comes to pricing, you need to be able to make a decision about how much is an impression worth and how much should you bid on it, given that so many of these auctions are first party today. Then you have control systems. So you're going to have a prediction about how many bids you're going to win and how many impressions you're going to deliver. Those predictions might be good, but they're always wrong. So George Box, who's a famous statistician, has this quote: "All models are wrong. Some are useful." So you have to recognize that your models are wrong as well. So your control systems need to be able to continually adjust and modify what you're doing. But it's also important to say that within those algorithms, there's different levels of sophistication in terms of what you can do. Rex, earlier you mentioned lookalike models. So this is something that's people often talk about, a lookalike model. And the reality is that every model that's ever been built is a lookalike model. What you're doing is you're starting with some data and you're trying to build a model that can predict or classify based on that. But there's essentially an infinite range of ways in which you could build those models, and they vary massively in terms of sophistication and value.
Hey, Konrad, is that noise on your side, by the way? I hear a lot of noise in the background.
Excuse me.
Yeah. Something. Yeah, I can hear a lot of it.
Excuse me.
So it felt like a construction. It felt like they were like redesigning the school lunchroom or something. I don't know.
We have to stop. Sorry.
Yeah, I assume Mary can probably cut out a lot of that, but I was like, it was if he's doing most of the talking.
Sorry, guys.
Yeah, that's all right. Okay, yeah,
Hey
there
guys,
we go.
can you come back and do it later?
Yeah, 20 minutes. Yeah.
This is like the prediction of the model, like you're going to have an hour to be able to do a podcast. To your point about the model not always being right. And then the adjustment to the data as it comes in.
We're going to get to the point where not only can it interpret and remove all of that noise, which is probably a fairly straightforward problem for these neural networks these days. It'll be able to take our pieces and recreate it with our intent, and we'll be able to do that. I mean, we still have a little bit of the uncanny valley.
Yeah. We're doing that we're doing a training series with the Marketing and Media Alliance, and the last exercise in the yellow belt is you take all the transcripts, which is over 100 pages worth of content. Then you have a critic agent say, watch the news, what's changed that would make us need to change what we just trained you on.
God.
And then it uses Hey Jin, an avatar of me and my voice. It writes the script and then it reads it and presents it back. It feels a little mechanical and the intonations aren't quite mine, but it's close enough. To your point, it's the uncanny valley. But my God, that already exists today. And the key thing is the quicker people learn the tools of what you're describing, the better. But my thought, and the reason why I was really interested in you as a guest, is your ability to describe that you can't just leap to using the tools. You need to have some understanding of what's underneath the tools, the machine learning and the decisions that are made, some of the intentionality about trying to use a machine learning model versus, like you said, the expert system where all we've done is we've taken a decision tree and we've automated it. That doesn't actually bias as much as changing the way we're thinking about how you said signals, not segments, the way we begin to think about that information and that automation of that data. What do marketers need to know or do to get to the world you're describing of that integrated machine learning systems? What advice would you give?
Few things. Be curious. You got to try these tools out and recognize that not everything you're going to do is going to work. In fact, most of it probably won't work, and that's okay because you're going to learn from it, and you'll stop doing the things that don't work, and the things that do work, you can you can use those for a long time to create value. The breakthroughs in large language models have made AI much more accessible. So you don't need to write code. You can talk to these machines to get results. It doesn't mean that using AI is always the best solution. So people will use AI because it's easy, but sometimes a deterministic approach is going to be better depending upon the problem. And when you want to build complex production systems, things that you're going to rely on every day, day in, day out to spend thousands or millions or even billions of dollars, you've got to really think about how these things are working and how they're interacting. And maybe in the future we're going to get to a place where we can describe what we want to do, and an AI system is going to go and do it all for us. We're not there today. Today it takes careful design and testing and organization.
Wait, Konrad, I think it just happened. Have you used Claude Cowork yet?
It's interesting, right?
I mean, you totally makes me understand why. I mean, I don't know all this going on behind Manus, but Meta, right? Meta paid $2 billion for the thing. And Manus was basically doing exactly what I think Claude Cowork is. It is my impression of the thing. That it's a self-determining system. I mean, you guys use better words, but self-determining system that can really sort of solve all the problems and not just do the task, but then think through the task and check the task so that then it knows it's doing the right thing. It's like it's a perfect assistant who knows me and knows the problems and is able to call them out and then give me options in an intelligent way that an assistant would have challenged me to do. So it feels like that Claude Cowork is there, right?
Absolutely. I think for certain types of problems, it can work out how to break that down into constituent tasks, how to check its work along the way. But if you require a level of repeatability, not just for your own tasks that you're checking, but something that's running on a fully automated basis, you still need to have guardrails in terms of how those systems operate. That's certainly a view for the future, and maybe in the future you can describe the problem, and the AI, if we reach superintelligence, the AI will go and invent all of the technology that it needs to solve these problems.
We'd heard, I don't know, tell me if we're wrong, maybe, I don't know if you know, I mean, you're out in the valley, so maybe you hear stuff, but that Claude, Anthropic, actually had only decided to build that recently, and they asked the AI to build it for them, and then launched it within less than 12 days, I think. Would you know that? That feels impossible, but...
Well, I think that there are, the AI coding tools, the coding assistants can greatly assist.
Are crazy.
In terms of putting together systems. Now, I think we're still in perhaps the early stage of sort of real breakthroughs in sort of algorithmic design and system design with these solutions. But for companies that are training on their own intellectual property, because of course a lot of the real breakthroughs aren't available on the public internet for these models to train from. They're hidden away in companies as trade secrets and things like that. But absolutely, we're on a path where we're going to see systems coming up with novel ways of solving problems, and we've seen that. We've seen that over the decades. I think we're seeing that accelerate rapidly now.
If there was one thing that you'd want to have fixed that would make online advertising so much better in your experience, do you know what that is? And I'm asking kind of a both, you do, okay, both what it is, and I'm asking technically. I'd like to go a little more technical about how you actually do that. Yeah, go ahead.
It's not, this technical is part of the solution. It's measurement.
Yeah, no shit.
It's measurement. That's the most important thing, because it's the objective. It creates the incentives.
Why are we still so bad at that, Konrad? Do you know? Because we really do suck at it.
Because it's hard, and because there's often less funding available for it. But it's important. Incentives drive goals. People follow incentives to get to goals.
Yeah.
AI ruthlessly optimizes towards goals. So be careful what you wish for. Really think through what you're asking it to do. And it's just about being disciplined. There's certain things in measurement will always be hard, but thinking through exactly what are the objectives you're setting for a campaign. How does that relate not just to a campaign metric, but to your business goals? I think too often that gets lost in translation through the process. And it really
That's such an
matters,
important
because
point.
that's what you optimize to.
It's such an important point. I mean, I think that there's two things that are happening that are really interesting on the measurement front. One is that the attribution measurement was designed for a world in which people used one device and connected from one place. It was developed before we even had 4G, let alone 5G. And so most of the measurement and ID graph and so forth does really well when people are at home on their residential IP address. It doesn't work so well when they leave home and they're on a cellular connection, or they're moving between devices. They started on the desktop and now they're on their mobile phone and now they're out of home and cellular. And it's been like a slowly melting ice cube that's made us begin to lose more and more attribution signals of the customer journey of someone seeing an ad and converting because of that cross-device, cross-location connection that I don't think we've reconciled as an industry at all. The second one I think that's really interesting in your point is be careful of what you wish for. I mean, I think the alignment problem in AI is that if you say, I want sales, what does that do? Well, it systematically moves your advertising towards people who have already bought from you before. And it underweights the people who have never bought from you before because a person is about 5 to 7 times more likely to convert if they've bought from you before. And so you've now just shifted the audience. Unknowingly, you've eroded your ability to create future sales because you're not investing in the top of the funnel or the awareness building and so forth because it doesn't convert as efficiently. So a more nuanced one is I want to maximize lifetime value, or the term in which you want to define your profitability or success. Another way of getting sales really quickly, back to your point about adjusting the message and the audience, is to put a deal offer. So now you might be giving 20% off, but you're doing it to consumers that would have converted anyway. So your incentive of trying to get lots of sales right now gave away your profitability because you focus on sales and not profit. So there's a bunch of things that marketers haven't really thought deeply about because they've never had any algorithm or AI that could optimize so viciously, accurately, quickly that they've really had to deal with the lack of precision in saying, oh, I want to drive sales. Well, do you really? And over what time frame? That's a totally new way of thinking. So I'm really glad you brought that point up. So how do you think about trying to balance a long-term and short-term, and what do you really want to achieve, and what are those objectives?
I think there's a few levels of addressing that, and they get harder the longer the time period is you look over them. But on the short term, on a campaign basis, so you could optimize for sales, try and maximize a CPA. But as you mentioned, that doesn't necessarily take into account your return on ad spend or your lifetime value or your margin contribution, let alone your incremental margin contribution. So the more of that information that we can be provided through a tag or through our conversion API, we can optimize for that rather than optimizing for number of sales or lowest cost per sale. You can optimize to, the highest return relative to the lifetime or predicted lifetime value. And the system will do that automatically. It will optimize to the goal that it's given. But then you sort of work it out over longer periods of time. You have to address at each period of time, but as you go along, you have to address that ID graph piece you mentioned. And we use machine learning algorithms to build our own ID graph. That only solves part of the problem because that's what we're measuring, but obviously different partners, different advertisers we work with might have different measurement systems. So you have to look at how these things align. And then as you go over longer periods of time, you think about what are the measurable moments and inputs that you can put into this, and how can you tie them together over time so that you can be confident that you're driving the right sorts of awareness, consideration, favorability all the way through to sales. But obviously I think what you're ultimately getting at is what's the right balance of budgets between those different stages as well to maximize that long-term value. And the data sets are still hard for that. So there's still I think a lot of judgment that's there, but we are tying these pieces together with instrumentation all the way through.
So the issues are a lack of marketers' understanding of their business and their business goals completely is part of what you're getting at. It's not. There's certainly a set of data that we still don't have comprehensive, and we may or may not be able to collect. But it has nothing to do with processing. It has nothing to do with any of the other tech involved in AI machine learning that we need. Does that have to develop further, or?
No, I think with the data, we have the modeling capabilities to do it. I mean, one of the reasons that we tend to work primarily with performance marketers and ones that have extensive interaction through their own customer experience, contact points, is because they have the data. They have the data, and machine learning works much, much better when it has clear data and clear signal to optimize against.
Yeah, you're much better off in a business like retail or subscription businesses where you know the customer compared to CPG where you're selling through a channel and you don't ultimately know who the end customer is. But my view, Greg, and your question, it's a good one to sort of wrap the show up on, is if you are in those areas where you are in a subscription or retail or you know who your customer is, what are you waiting for? I mean, you need to run faster, right?
Yeah, totally. Yeah, they should
So,
lead the way.
Konrad, last question here. What do you think is overhyped and is distracting people? And what do you think is, like, if you were to wake up tomorrow or later on today and say, hey, marketer, your team, you need to do this today, what's that one thing?
Gosh, that's such a hard question to answer because, technology can both be overhyped and utterly transformative, depending upon the time horizon. There's a lot of hype right now. There's a lot of hype of what I think of as sort of large language model veneers on top of systems that may have some utility. But this will play out. Performance is going to matter, and we'll find out which emperors have no clothes.
I love it. I think you're right. I think you're absolutely right. If in doubt, test them both and be an empiricist, see which one produces.
I'm afraid we're not figuring that out, but that's for another episode, I think, Rex.
Yes. Well, that's it for this episode of Decoding AI for Marketing. I'm Rex Briggs.
And I'm Greg Stewart.
Be sure to catch all our episodes, plus subscribe, follow, rate, and review in your favorite podcast app, or check us out on YouTube. You can get transcripts and more information on our website, decodingaiformarketing.com.
And if you want to learn more about Marketing Media Alliance and the work that the MMA is doing to sort of help marketers here, please go to MMAglobal.com or reach out to me. Thanks, everyone, for listening. Konrad, thank you for doing this. Really appreciate it.
Yeah, thanks, Konrad. Really good to talk with you.